So can you see my screen?
Yes.
Okay, nice. All right. So yeah, let's start. In this,
Do we want to start recording?
I think I started recording.
Oh, cool.
Yeah, I have already started recording. Yeah. All right. Okay. So in this session, so we'll discuss the fundamentals of GraphQL. So these are the topics that I'll try to cover. Basically, I'll start with REST API because it would be easier to understand GraphQL or the importance of GraphQL if we have some background on REST API first. And instead of directly answering what is GraphQL, why is GraphQL, I'll just compare GraphQL with REST API. I think in this approach, it would be easier to understand. All right. And there are three kinds of questions like why, what, and how. So how to implement a GraphQL API? That can be answered by different books and resources. Even GitLab has a good documentation. So I don't want to spend too much time on that. Rather, I'll spend time on why and what is GraphQL. Okay. So let me start with REST API. So REST API means representational state transfer. So this may seem confusing, or like I find many authors find it like this definition quite meaningless. So let me give you a better or simpler version of what is REST API. So REST API is all about resource. Just think about object in object-oriented programming. So if you heard the word resource and just visualize that this is just like an object in object-oriented programming. So a resource may be singleton or a collection. That means a resource may be a single object or a collection of objects. Let me give you some real world examples of resource. A resource may be a book. It may be a collection of books, or a resource may be a particular author or a list of authors, and a particular review or a list of reviews. So anything, so REST API is all about handling resource. That means reading the resource or modifying the resource. For this, REST API may have a number of endpoints like get here. For the first one, get, you can get a list of books, or you can get information about a particular book. You can add a book to a collection of books. And we have put and delete. So you can see, in order to handle a particular resource, in this example, the book, you need to have at least like 4 or 5 or more endpoints in REST API. So this resource-based REST API is called pure REST API. I will explain what is pure REST API and what is REST API later. But for now, remember, whenever I say REST API, that means it is pure REST API, and it's all about resource. Now let me compare GraphQL and REST API. So you can see, in order to handle a particular resource, suppose a book, you need to have 5 or more endpoints, right? But if you want to do the same thing in GraphQL, you just need one endpoint. That's it. Moreover, like, you just need only one API for, one endpoint for GraphQL for the whole application. For the whole GitLab REST monolith, there is only one endpoint, GraphQL API. but there are many REST API endpoints. So you can immediately see here that you don't need to handle creating a new endpoint whenever you need to require a new information. You don't need to create any new route on the server side. Okay. So this is one difference. Now let's look at another difference. There's a concept of underfetching of data and overfetching of data. So you can see in REST API, so for this GET endpoint, if the client make a request to the server that, hey, server, give me the information about this particular book with ID 234, then the server will return back a, a, a number of field, a JSON with number of fields. That means it will just return the full information about that book. This may contain a number of maybe 5 to 8 fields. You can see here ID, title, author ID, price, right? So it will give you the full information about the book. But in GraphQL, you can specify. The client can ask the server that, hey, server, give me the information of this book, but wait, don't send me the whole information, just send me the title. Okay, here you can see it's requesting the server that just send me the title or just send me the title and price. So here you can see the response size in GraphQL is it's reduced, right? The response size is smaller compared to the response size of REST API. So here I just asked for only a particular book. Think about thousands of books or 10,000s of books, okay? So then you can see the benefit here. So you can ask the server, the client can ask the server, hey, server, give me the list of all books, but don't send me all information, just send me the title and price of all the books you have in your library, okay? So then the response size will be very small compared to REST API. Another difference is the versioning. versioning. So in REST API, if you want to maintain a version, you need to apply v4, v3, or like you need to create a new version for each, if there is any major change to your endpoint, okay? Suppose in this example, the first one, this is REST API. The first one is v3, and here you can see the field was cost, but later version v4, the field becomes price. So whenever we move from v3 to v4, we just change the field name from cost to price. So this may break if the old client is using v3 and then you force the old client to use v4, then you can see here the code will break there in the client. The code will break. Another thing is, like, whenever you know about whenever you create a new version of this endpoint, you need to let the public know about your publishing of new version. You need to update the documentation related to that, okay? So in GraphQL, there's no versioning. That means you don't need to maintain v1, v2, v3, okay? What you can do, you just need to add a new field to your GraphQL endpoint. So you can see here, the first request, the client can ask for the cost field, okay? In another request, the client can ask for price, okay? So the client will let the server know what it needs. It needs cost or price, all right? So it will both of the fields will be available. And in GraphQL, there is another good mechanism to deprecate a particular field. So whenever you deprecate, suppose cost, you want to deprecate cost. So you can let the client know, hey, client, you are using cost, but this field will be deprecated. So you should switch to price. Okay. So you can see the communication between the server and client is very smooth here. Okay. Now about the documentation. So let me go to this page. You can see for REST API documentation, whenever you create a new version or if you add a new field, you need to go to you need to update this documentation. There are some tools for doing that. There are a number of tools. There are some automated tools. That tool just send the call request and get the response and then update this document. Okay, this is how we do it in REST API. But in GraphQL, actually the documentation is built in. Okay, you don't need to maintain any third-party tool for updating documentation or creating a new documentation. All right. So let me show you. So this ID is called Graphql, although it's pronounced as Graphql. So whenever here you can see, if you want to know about a particular field, suppose here level, you can see immediate documentation there. So the documentation is first class in GraphQL. Documentation is built in, and GraphQL always forces to write you to write documentation.
I had a quick question. As far as docs, so this is the tool I use, and it's really nice with the autocomplete and letting you know what fields are available. Because we have the docs here, is there anywhere else that we have the docs documented in like the GitLab documentation, or is this the only way we know what's available at the endpoint?
There is the GitLab documentation as well. For
Okay.
yeah, I forget the link, but you'll find the similar documentation in
Okay.
GitLab.
All right, thanks.
So the documentation, so you have both here. You can see also you can see GitLab own documentation. And yeah, another thing is like here you can also search for a particular field's information. CI then. So the GraphQL actually forces you to add documentation for each field, and it forces to publish the schema. And the client can know about this, and you can see the front-end development would be faster in that case. You don't need to go to a particular page that may not be updated by this time. But you can go to this IDE and you can immediately see the documentation. So this is instantly updated whenever you publish a new changes for GraphQL API, GraphQL endpoint. It will be instantly published. All right. Okay. Now let's talk about telemetry. Suppose you want to know about how many users are using a particular API. Okay, so you can add metric and you can see the telemetry, and you can you can get the answer to this kind of questions. Okay, how many users used this API for last 2 weeks or for last 1 month? Okay, you can get those answers for REST API. That's good. Okay, but in GraphQL, you can get that information at more granular level. That means you can ask this kind of question. Okay, how many users asked for title of the book for the last 2 weeks? Or how many users wanted to know about the price of the book for last 3 months? Okay, so this kind of questions can be answered in GraphQL, the way it is implemented. So more granular, more insightful analytics you can get if you use GraphQL compared to REST API. Another thing is like you can also monitor the performance of a particular field level, like the performance of getting the price information, performance of getting a particular publication information. Okay, but in REST API, you can get the performance information about a particular endpoint. Okay, not at the field level. Okay, so let me talk about some GraphQL operations that we mainly use. These three are the main operations. Like one is query. Query is similar to get in REST API. The GraphQL query is similar to get. Then GraphQL mutation is similar to post, put, or delete. Okay, it's all about modifying data. And subscription, this is for WebSocket. So the good example of WebSocket uses is Slack or Facebook Messenger. In this case, the server actually pushes the data to the client the other way. Suppose in chat application, you can instantly see what other people are replying to a particular channel. So this is an example of that. Okay, so how can GraphQL helps to reduce the round trips? Okay, so the first example you can see for pure REST API, if you want to know about different informations about different resources, then you need to send multiple requests to the servers. Okay, I want suppose first in the first request you want to know about the books. Okay, server, give me the information about the books. In the next request, you can ask, okay, give me the information about authors of these books. Give me the information about reviews made by those authors or made on those books. Okay, but in GraphQL, you can just do it in one request. You can just directly ask the server that, hey, server, give me the information of books, authors, and reviews, please. Okay, and the server will just calculate all this information based on the database query or extracting the data from other data source, and it will just combine them into a single response. And it will, then you will get back, the client will get back that response. This is how it works in GraphQL. So you can see here the round trip is reduced from a number of round trips, like here from 3 round trips to 1 round trip. Okay, this is very fast. Okay, now let me talk about REST-ish API. Okay, so the way I compared GraphQL against REST API, we tried to solve different issues related to REST API. Okay, suppose we said that you cannot specify, you cannot tell which fields to grab. Okay, the client cannot specify which fields to the client wants to know to REST API. But there are ways you can modify the REST API. This is called REST-ish API. REST-ish API looks like REST API, but it's not actually REST API. It is a customized REST API. So using REST-ish API, you can send a list of parameters to the API. And suppose the parameters may be a number of fields that you just want to know. Okay. The bad thing about REST-ish API is you need to manually do the filtering on the server side. Like you need to manually on your backend, you need to manually create that response by filtering by those fields. In GraphQL, this is by default provided. This is provided by default. In GraphQL, this kind of boilerplates are already hidden. It's already implemented. It's already implemented in GraphQL. All right. So yeah, REST-ish API is good for smaller project, but whenever the projects gets bigger, and then you can see using GraphQL has benefit over that kind of implementation of REST-ish API. Okay. Okay, let me now ask this question. What is GraphQL exactly? So I just showed you a comparison of GraphQL against REST API. So what does actually GraphQL solve? It's actually solving the communication issues between client and server. Okay, so in GraphQL, the client can tell exactly what fields it needs to grab from the server. So it's not overfetching, it's not underfetching, it's just getting as much information as needed. Okay.
I do have a follow-up question, and maybe if you want to circle back around later, but what about security, right? Because you're saying client can request certain fields. So is security still enforced for fields that are not, that you don't have permission to access? Is that something that we have to enforce, consciously think of when you're doing backend development? Or does GraphQL make that very easy to do built in?
So yeah, good question. So here's the problem of authentication and authorization. Okay, so GraphQL doesn't provide any mechanism for authorization. You need to do the authorization on the back end. Okay, just like other APIs, even in REST API, it's not by default provided. Okay, but there are many implementation of GraphQL there. You can enforce the RBAC, the role-based access control, and so authentication and authorization should be a separate service. The GraphQL's, it is not the responsibility of GraphQL to ensure the authorization and authentication. Okay. Yeah, I can talk about the security issues later, like DOS attack, denial of service. But yeah, in GitLab, we also handle that RBAC in GraphQL actually. So, so here I can mention that GraphQL is just a specification. Okay, it will just specify how to communicate between client and server, but there are different implementation. So there is a Ruby implementation, there is a Node.js implementation, okay, and it's not attached to a particular framework. It's just a specification. It's just a standard. Following the standard, different backend server has different implementation. Okay, and it's a declarative language in the sense that it's similar to SQL. In SQL, you can ask for select uh, title from books. That means select the field title from books table. Okay. So in the same way, you can say, the client can say, okay, give me the title of this book. Okay. So you can see it's just a query language. Okay, there are some misconceptions about GraphQL. Let me describe them. So one misconception is like GraphQL, as this was developed by Facebook, and React was developed by Facebook. There's a misconception that GraphQL can only be used by React. Okay, but it's totally wrong. GraphQL is not specific to a particular language. The implementation may be in Ruby, it may be in Python, in whatever language you use, but you need to follow the standard. That's the thing. There are a number of libraries for that. Okay. There's another misconception is that GraphQL is related to graph database. No, the underlying database may be anything. It may be relational database, it may be NoSQL or graph database, even a simple JSON file. Okay, it's not related to graph database. This graph word, the graph in GraphQL, comes from that idea that Facebook is looking at the data as a graph. They think about data as a graph. Okay, this is just about how do you view data. It's not about how do you store data. And the Facebook, they think data as graph. That is why it's called GraphQL. Another misconception is you can see the n+1 problem with database query. Okay, so GraphQL solves the n+1 request problem with API server. Let me show you this. So you can see here, this is our API server. You can think it as a Rails server. This is our client. This may be a browser. Okay. So GraphQL solves this connections problem. GraphQL solves the n+1 problem with this connection. It doesn't solve the problem with this connection. So for n+1 query problem with the database query, you need to solve it by yourself in the API server. Okay. Right. Okay, so yeah, these are the resources that I use, like GraphQL in Action. I use this book for this presentation, and also I use the official GraphQL page. This is also very helpful. Like if you just read that page, you can see a lots of good comparison between GraphQL and REST API. Okay, any question? Or I can talk about security maybe, or do you have any question?
You could, I have a few, but you could do the security one if you'd like.
Sure. For the security, like as I mentioned, like let me find. Here. Okay. So this is our GraphQL implementation. There should be an authorized something like that. So I want to show you how we do the here you can see authorize. So in GraphQL, oh, actually, yeah, this is the RBAC in GraphQL. So this is how we authorize. Okay. So it has only read project. So if the user doesn't have proper permission, then the GraphQL will not render the other fields. Okay, this is how we do that here. Then let me talk about the DOS attack. Like some people may try to use DOS attack, denial of service. He can provide here multiple of same field. Okay, so maybe 100 times, repeat it 100 times. Okay, but whenever you do this, GraphQL will just return only one field. Although you have mentioned here 100 times, although you have mentioned level 100 times, it will just return once. Okay, this is one way it handles the DOS. Another thing is like for DOS attack, you can write a script, and the script will run maybe million times in a for loop, and it will try to hit this endpoint. Okay, so this is a problem, but this is not a problem particular to GraphQL. It is a problem with any API. It's a problem with REST API and other things. So we use you can use API limiting throttler to limit the API call maybe 100 times only for 1 hour for a particular client. This is how you can handle the DOS attack. Any other?
Yeah.
Yeah, oh, go ahead.
So on this one, I just had a question about like a recursive descent or something like a billion laughs attack. So if you have a project that includes one of like its head pipeline that could include a reference to another project, how do you prevent like a recursive reference in a GraphQL query? Does that make sense?
Yeah, I as far as I know, like you can, I don't know exactly, but you can specify in GraphQL that in the response size should not be greater than maybe 1 megabyte. There's a way, as far as I remember. Okay, I don't know exactly, but I'll try to find out that answer. So in
Okay,
that,
so
yeah,
so it looks like it's limited by response size rather than something like max descent depth or something.
yeah, something like that. Yeah. And another thing is like you can GraphQL just provides you the standard. Okay, and in GraphQL there's a facility to paginate and size of the list. Okay, suppose limit 100. So in that case, you can just limit the response size to 100, and you can also apply pagination. This is how. This is how you can handle those kind of things. But you need to handle those things in the backend by yourself.
Wouldn't that, I guess, have to be explicitly done in the resolver on the backend side? Because, for example, I guess what you're saying is like a recursive query, right? Where it's like, let's say a user has a bunch of projects and the projects belongs to a user, and then recursively kind of like querying that back. But I think if it's not implemented like that in the resolver, it's not going to keep like providing that option to request a user that has a project, that project then has a user. I'm not sure, but
okay, yeah, I'm not 100% sure. Yeah, thanks. Yeah, I'll try to find out.
I did have a follow-up question. So, you know, GraphQL, how much, like, would you say it's like a set specification? Because I know there's a lot of different implementations, kind of like REST, right? REST isn't quite, I mean, I don't know, there's like a textbook implementation of REST, but all implementations are variations of it. So do you mind describing, I know someone had linked in the Google Doc, the gems that we use. So can you talk a little bit about specifically about our implementation of GraphQL, which gems we pull in, and what functionality we get?
Sure.
You know, that may be non-standard or just in our context.
Yeah, definitely. So let me find out the link. I think I provided here. So this is the official specification. So this is the standard. So you can see this is the official specification, and this is updated by community contributors. But initially it was maintained by Facebook. Then they published it. Now it's open. Okay. So following this specification, there's a Ruby gem that we use GitLab, Ruby GraphQL. GraphQL Ruby. Okay. So we use this gem for that. So this gem is just implementation about based on this specification, and you can know about that. You can see here. You see, we added this gem in the gem file GraphQL. So this is that implementation.
Okay, and that makes sense. And I've seen those docs before. What about the GraphQL Rails? Is that just like a bindings for Rails? Just because I know like GraphQL is probably the Ruby implementation gem, and then the GraphQL Rails, I guess, is the
this one.
Yeah.
I guess this one is the graphical. Graphical means.
Oh, okay.
This for this one, you see.
Yeah, try that Explorer. Okay, fair enough. Okay, and then what about, so I guess I had some stuff on the Google Doc. So at least from the front end, I understand that we use the Apollo client also. So Apollo client seems to be, well, here's from the docs. Apollo client is a comprehensive state management library for JavaScript that enables you to manage both local and remote data with GraphQL. So I believe it's a GraphQL client implementation that adds some extra nice things like batching queries and caching queries. And that is compatible with any GraphQL compliant endpoint.
Right. That's true. Because you already it must be compliant because you have specified the specification. You have specified the standard here. Okay. So that is the beauty of GraphQL. GraphQL has a standard. It's already published. It must be compliant with other thing. But in REST API, there is no standard. That's the thing. It forces to comply with any client, any GraphQL client with any GraphQL server side.
And no, that makes sense. So the GraphQL endpoint that we have, like, is that basically a Ruby? Is that part of the core Ruby on Rails main, like the main web app that we have? Is it part of that service, or is it some other third like microservice, kind of like Gitlab and all that stuff, or is it incorporated as like a Ruby on Rails app? The main.
Yeah, it's not another microservice. It's part of monolith. You
Okay.
can see, you just add the gem, and it's part of Rails monolith. Okay, it's not like another microservice like Gitlab.
Okay, all right, thanks.
Another comparison I can give you. So think about ECMAScript and think about JavaScript. ECMAScript, you are specifying how should the JavaScript look like, but there are different implementation of JavaScript. The Chrome browser has a different implementation than another browser, right? So it's the same thing here. Like this is the specification, but there are a different implementation for GraphQL. Any other question? Yeah.
Sure. Just because I've been doing some of this stuff recently and more so in the future. So we have you seen a hybrid approach? So what we have in the front end is where you have a GraphQL query, you get back a response, right?
Yeah.
And then one of the fields is a reference to a REST endpoint. So I'll give you an example. We want to download all the artifacts for our pipeline. So we say, give me all the pipeline jobs that have a particular security report. Let's say API fuzzing, coverage fuzzing. What gets returned back is a message, and one of the fields is actually a URL path to download the artifact download. I don't know how we could request files from a GraphQL endpoint other than getting a REST endpoint back to then we could just serve that to the user. When you click on a button, it just hits the traditional REST endpoint and downloads. Like, is that pattern, are there purists for GraphQL? Is there any other way to do it, or is that like a common one? Because it works, it's fine by me, but I don't know what your opinion was about that.
Yeah, I haven't seen anything like downloading files in using GraphQL, but I'll try to get that answer. I'll get back to you. I haven't seen anything like that in our GitLab project. Also in this book, I haven't seen anything mentioned about that, actually, how to download or upload a file using GraphQL.
What I'll do is I'll link in this was actually done recently. So Ross maybe could speak to it if you wanted to. Like, no? Okay.
All right, I'll look into that. But
no worries, yeah, because it's interesting. File downloads traditionally in general have always been like that one-off case. So
okay, cool. Yeah. Okay. So yeah, if you okay, yeah, I think we already passed like the time. Yeah, maybe I'll do another presentation later on more details how we can implement a particular field in a GraphQL. Then it will be more clear. Okay, yeah. Thank you for coming.
Thanks for putting it together.
Yeah, all right. Okay. Right. See you.